Hi, everyone. My name is Lina Yang. I lead intelligence system, and I'm operational director for the Fremont office. Supernal has a three different office, and we do have autonomy and a a center of excellence here at Fremont. And we've got great set of algorithmic designers, and when it comes to autonomy problem, and or when it comes to battery management problem. So that's where I sit, and that's a Fremont. All right. So when Ricardo was asking me if I can give a lectures about advanced air mobility, I thought about what are the topics and what are the sort of the contents that you guys might be interested. If you Google it up and if you look it up in research papers, there are various different great papers and great presentations about explaining about the advanced air mobility. So I thought that if you can actually get all of this knowledge through that your Google search, what actually do I want to give it over to everyone today? So I try to put my deck with the emphasis of what's currently most relevant as of 2024. I don't know what's going to happen 2025. There are smart students and professors and engineers around the world will actually come up with a brilliant idea of solving some of the problems that I present today. But I'm going to be more focusing on the most relevant problem of 2024 and where I see the gap, so that if I can inspire all of you that in terms of, hey, try to write research papers, what are the great topics? Try to launch a project, what are the great project ideas? And what's the most relevant to the industry? And if you're sort of curious about that, I'll be more focused on that. Agenda. So advanced air mobility, I mean, you've seen various different pictures and the various different OEMs and everyone coming up with a very different configuration of the vehicle nowadays. But the keywords here that I would like you to have in mind today while I go through my deck is remotely piloted, automated. I don't like to use autonomous, but sorry, I noticed that I put the autonomous there, but it's highly automated, and eVTOL, and intracity and zero emissions. Those are the sort of the keywords that you want to keep in mind while we go through this deck. So I want to start with typically in aviation, so what is a driving force? As you see, I'm not going to read through the deck, and in here that because of the jet engine revolutions, that's where you see that we're now able to travel around the countries and with a couple of with a few hours and even crossing the continents. But you do know the problem with the current existing jet engine, which is that emissions is high, and the noise is absolutely loud, and although the vibration is quite low. Third generations, the whole driving force of UAM right now, it's the inventions and actually capable to do the commercialization of electric motors, which has that zero emissions because we're using the electric battery, and then quiet because we're using the distributed electrical propulsions and the technologies. Distributed electrical propulsion, I mean, you can search it there are a set of great papers out there, but in short, it is the capability of that we're isolating the thrust producing propulsor, jet and vent, with the power producing components, which is a traditionally engine, and those two systems do not necessarily share the same mechanical power transmissions system, and because of this decoupling, and because that power producing components can be combined with the energy storage system, battery. We're giving the freedom for the thruster producing propulsions to come up with, to use any variations of any devices that meets the various sizes and a type. Because we can decouple this, you're seeing all of these crazy ideas of the design of the vehicle that you see out there. Some of them are example in here. And one thing I noticed, I didn't put the Supernals in here because I prepared this deck for like a couple years for a different conference. I should have done that. But if you search it up, we do have SA2 versions that we announced several months ago. But And the point here is that, and these are the driving sort of technologies behind it, and hence that you see the various different configuration, which gives a FAA a headache. Like, how do we certify this vehicle? These are the brand new vehicles, the type of configuration that we haven't seen before. Hence that FAA is taking time and then working with the industry that in order to come up with how do we ensure the safety and how do we certify this vehicle. I'm going to come back to this one because that poses quite a lot of challenges because we're introducing that energy storage system. Briefly, what are the type of missions? Again, I'm going to go really quickly because these are the information you can search it. I'm focusing on short-range urban air mobility, the people-carrying vehicle. But there are various different types, and when it comes to regional air mobilities, and we could actually potentially put quite a lot of people there. But primarily right now, the focus for the RAM is for the cargo. Short urban air mobility is that the payload is around 1,000 pounds. And the people, about 2 to 5 passengers, and depends on the OEMs, and it sort of varies. And the distance, we're thinking about 10 to 70 miles per trip. Infrastructures, keep in mind that we need a place to land our vehicle and to take off their vehicle. Those are very different set of the configurations than you can imagine for the helipads. And because of the new vehicle infrastructure, the configuration that we're introducing, regulatory requirements are non-existent at the moment. Now that after several years of working with FAA, with the industry, we have a somewhat good understanding now. But these are the type of stuff that overall that not just the technical industries that is the problem, but it's a more overall problem that involves quite a lot of regulatories as well. In terms of market, not going to read through. Those are really large numbers that, and there are quite a lot of people doing the assessment about how large that the industry is going to be. But as you can see that, and then it actually enables large set of the market if we actually know how to automate properly, and which one of the keywords that I mentioned before, and by enabling multiple different infrastructures and the players that we're introducing newly to the industries. The Elevate missions, these are the very different missions than you see on currently. Fixed wing have a very different profile. You take off and then you cruise and then you descend. Helicopters is a completely different as well, right? You vertically take off and you do the cruise and then you land. Here, because we're able to transition our thrust and the lift, we actually take off like a helicopters and transition to similar to the fixed wing, and then we do the ascending, and then we continue cruise, where it's the most optimized with the fixed wing like configurations. And while we try to descend, we change our transition, we change our thrust again to be able to vertically land. Complete different set of the configurations, complete different missions. Again, that poses quite a lot of open, interesting problems as our industry goes. Corridors. You do know how the large commercial airliners fly. Class A, Class B through the Class A, very, very high altitude. You don't necessarily see them. We keep it such a way for many different reasons. You do know the helicopters. You don't see that around the city because of how loud that is and downwashing effect of the one rotor. When if we're gonna be deploying this vehicle into the city, like Berkeley, San Francisco, connecting with San Jose, it would have to fly right above your neighborhood, your residential area. And the problem that we'll be facing is a very, very different set of the problem that existing aviations have been solving. We're going to be facing with many different cooperative and uncooperative agents and in the airspace, and as well as a terrain problem that we are facing right now, it's a complete different magnitude than that of existing problems. I'm going to talk more about that, but the idea here that we're implementing with and then doing the exercise and the experiment with the FAA and the NASA is that we should build the highway, the corridors for UAM specifically, so that none of the other vehicles can enter. Well, no. Other vehicles that should be, they can enter in here, but it's a primarily dedicated for UAM operations and emissions. So those are the concept that we're building. That is a notional highway up in the airspace. I briefly mentioned about the vertiport, where we're actually going to take off and land. Has to be within the city. Where next to your campus, at the Berkeley campus. I think that was one of the projects that we discussed with Ricardo, and or nearby next to your residential area. It poses a complete different, now that if you think about it, airport and helipads, those are sort of owned and maintained and then by the FAA. And then we've got whole regulatory framework around it, and we know how to manage it. We know where to put, airport and how to manage it and how to get it certified. And regulatory, the framework is already exist. If we put it inside of city of LA or San Francisco, now that we would have to involve the city planners, city mayors, and that understanding that because they're much more interested in here, because in case things happen in here, or can they use it for any of the emergencies, like for dispatching, for working with a fire department and whatnot. So we need to establish a good understanding with the use cases and regulatory, and then getting it certified now with the city mayors, so that entire industry gets quite complex with a different authority. So I'm going to talk more about the technologies and the gap, as I promised you guys in the beginning of the sessions. It's starting with the electrical, their motors and propulsions, and there's a battery technologies that I'll briefly go over. And there comes the sensors, because we're automating our operations and emissions. And there's an AI and the softwares and ML. We need a data. We're using heavily on in order to when it comes to sensor fusions, and as well as making decisions. Those are the importance and that we're working on it. And that actually requires quite a lot of heavy compute power. The whole point that you're seeing the automotive ground level vehicle is because the compute power was available in the GPUs and able to actually gather all the data with the cloud. And we have a large storage where we can train all this data. When it comes to aviations, I'll talk a little bit more about that, how wide that's posing the problems. And the satellite communications, because I briefly mentioned about new agents or the roles and responsibility we're adding in here into the UAM industry. Typically in the aviation industry, except that general aviations, if you want to control your missions and make sure that you're handshaking with the authority, it's been done through the voice with the ATC and the pilots. And then there's now ADSB is the sort of only mechanism that we're sort of broadcasting and then sharing the intent digitally. Now that we're enabling multiple different, we're actually inviting multiple different roles and responsibility players in here. We just cannot do that with the digital, with the voice communications. All the communication has to be digitalized. That requires different set of the communication protocols that we can reliably rely on. So I'm gonna touch quickly about that one. And then also advanced materials and systems, and then some of the robotics problem. So I'm going to go back to this stack, because right after DEP that I mentioned about the energy storage system that we can decouple the power producing components and with the thrust. These are I briefly mentioned about, how we take off and climb and cruise and descend and landing. Those are a very new emission profile that for the UAM. One thing that we would have to be also put it as part of our nominal mission is that emergency diversions. In case that where things are happening on the vertiport on the path where we try to land, where there are some things happen, or in case that where that fire department want to utilize their body part, for example, for whatever the situations. Electrical energy storage system for eVTOL would have to have those reserve. It's not like you're driving your vehicle and you've got some issues so that you can just park on the side lane and wait for do something. But we would have to make sure that we've got enough energy, and then because we're considering that as a nominal cases, and we would have to make sure that up there on the corner, those are called the reserve energy. Those are mandated by the FAA. Right now, as of today, FAA's mandate is a 30-minute reserve. If you remember my the introductory slide deck, I said anywhere between 10 to 70 miles of missions. And our target here is from San Jose to SFO, San Francisco, that we want to complete the mission in 15 minutes. Reserving 30 minutes is a very, very, very high toll. FAA is putting that because for uncertainties, right? And the electrical, the energy storage system, as well as a power producing component, is completely brand new. And we do know battery is very inefficient when temperature is low. So considering that we're flying high, right? And then that we're gonna be, those are nominal problem for us to face. So they're very scared, and we don't have much of the data. And then when it comes to when the use cases for it is that we require high number of the specific powers when it comes to hover and a cruise. I'm not going to go through all the writings over there. You guys can take a look at it. The only thing that I want to tell you here is that if you consider that emergency diversion as our nominal cases, that's where we can use the most of the energy. Hover, takeoff, and hover for landing. That's where we use the most of the energy, and the magnitude of the energy that we use compared to EV battery is, you can take a look at that little diagram over there. It differs per scenario. It differs per the use cases, but those are the sort of the magnitude of the problem that we're solving. On top of it, we would have to cap the reserve. So if we can increase the number of the battery, but I told you that we're 1,000 pounds, so there's only so much that we can add it onto the vehicle. And if you're putting the more weight of the vehicle, there goes the efficiency of your vehicle. So those are the trace studies, in case that anyone is interested in the batteries and then want to dig in more here. Those are the 2024, that these are the problem that we're facing right now. And that, having the great balance between the trace studies of the weight of the batteries, as well as reserving the optimizations of how we're actually going to deploy our power over to DEP, so that with a given number of the energy, that how efficiently that we can use it. So it also talks about the same thing, more in a different sort of graphical format. As I told you that how the takeoff and a hover and then landing is where we use the most of the energies, and in comparison with the battery technologies. So these are the depth of the differences that if you're thinking like, hey, we already have all the automotive using the batteries, so easy to deploy over to the UAM. Complete different set of the problem. When it comes to situational awareness, I did talk about cooperative, uncooperative agents briefly in the previous stack. Because we're flying on a lower altitude, think of it like, and then when we're building this UAM vehicle, we should be able to fly through somewhere like a Manhattan. Quite a lot of problems, right? And then these are the terrains that the problems that we would have to solve, and these are uncooperative agents. Solving how we actually going to be identifying and solving the problem is also biggest problem when it comes to situational awareness. So the sensors. Gonna actually move it over here. So these are the new type of sensors that we're deploying in the aviations. Just like a battery, yes, some of those technologies are already sort of matured and commercialized on the automotive side. Where when it comes to sensors, that we're talking about a similar set of the sensor. Radar, lidar is not so much, but the cameras, when it comes to thermal and IR cameras or the visual cameras, and then coupling that with the understanding of with the software stack on top of it. Just like a battery, we're facing with a different problem. Automotive side, it's more near distance problem. They care more about, hey, is the 5 years old boy will, he's playing with a ball right there. Is he gonna kick the ball in here? Then do I have to be worried about it? So the camera sensors, they're detecting the unknown objects around the vehicle is more the near distance problem. We're flying fast. We're out, and so that the problem that we're facing in here is a longer distance problem. So current set of the radar and the camera is not going to solve our problem immediately. So that's also another area that I am putting my heads down and what is this how we actually can solve the problem. Keep in mind the payload, we're limited with 1,000 pounds. The more sensor that I put it on the vehicle, heavier, less efficient, that use more power. So that with the lightest set of the sensors, which doesn't consume power much, but still solving high speed and high altitude problem. Oh, not to mention that we're six stuff, right? We're the 6 degrees of the freedom of. So when it comes to the understanding the unknown objects, it's a completely different problem than what the automotive industry is doing. So another area that I want to point it out, and in case that anyone's curious about sensors and object detection problem, these are the 2024 problem that I'm solving. Not to mention the lack of data. This type is lower altitude, like automotive industry. That street light, there are a bunch of different open source project where you can put your cameras and start collecting, and you can contribute it to the open source community. Not everyone can fly, especially that altitude. And collecting enough data for us to do the properly train and have a certified model out there poses quite a lot of problem as well. Yes, we can collect some of the data using drone and then defer, right? And then you can only do so much with that. So those are also the problem that I'm facing right now. And this understanding emergency landing problem is also quite one of the difficult problem. Unlike automotive, where you can, if you have anything happening, you just pull off on the side and then you can park it. Air vehicle cannot do that. Simply because I have an emergency, I cannot just land it on your backyard. I wanted to make sure that identify the flat surface and also have criticalities of that surface, and then have that good understanding of good understanding of that where that area is, real-time identifications of that regions. And then we definitely don't want to land our vehicle next to elementary school, right? Something like that is also the problem that I'm looking at it. So again, if those are anyone who's interested in sensors, object detections, and the visions, navigation visions, that I did mention. So going back in here, if you're going to be flying over to Manhattan, you probably, if you're driving down with your Google Drive, the map, as soon as you enter SF San Francisco or Manhattan, it stopped working because there's a GPS, there's a multipath happening. It's unreliable to get the whereabouts. So augmenting that to give the 100% confidence of reliability, availability, the integrity of where you are is the key enablers for automating our vehicle. So here, if you see that starting 2040 timeframe, we're anticipating to be growing with the market. That's because when we're anticipating that highly automated solutions should be available for UAM. Early deploying UAM vehicles are not going to be having any of these automated features, because right now the FAA's most concern is how do we certify this brand new shape of the configuration of the vehicle. And we're going to have a pilot. We're going to deploy with all the humans. You already know that pilots were suffering worldwide a pilot shortage. We're deploying hundreds and thousands of vehicles out there. If we cannot rely on the pilots. We need to automate our vehicle operations. And once we have a good understanding of this automated problem, that's where we're actually going to take off with the increasing high densities in terms of the operations. So AI ML, it's also a brand new headache that we're giving over to FAA. How do we certify, when you come up with your training modules, and then when you said your model is trained, how do we verify it and validate it and test it? Because this is no longer the software code where they can actually read it and then keep it their artifacts. I mentioned about the computing powers. Aviation is 1 to 2 generations behind. We just got certified about with the usage of the multi-core. Your phone, it's probably 8 or 16 cores. You've been using the multi-core since, ever since that we put out the smartphone. Aviation kept it a single core and a single dedicated function hardware for reasons, for redundancies, and with having the multiple dedicated function of computers and doing just so that in case that one box becomes unavailable or whatever malfunction, you still got 2 of the other box that you can actually back that up. I can't do any of this with a single core computers. Fusing the sensors and even just understanding that on real time, and I talk about the importance of understanding on real time, I can't do with the single core computers. So that's a major gap. That's a huge gap. And also the balancing it out, what's a bare minimum that I can do on a real time versus what is a pre-learned sort of the data that I can preload it to a vehicle. Understanding that the trade gap is also a good topic for research paper, your project, and because that is a 2024 the problem that I'm facing right now. Hardware is one thing. Now it comes to software. Ricardo briefly mentioned about software-defined vehicle. That is where my passion actually is. We need to move away from single dedicated hardware to general purpose, and then consolidating all of the functions. That way we can reduce the weight problem, deploy the multi-core, and then that's where you can introduce that virtual machines or Dockerize all of your systems so that your application can be Dockerized, separated out, and also and then that's where hold this that compute powers can be actually provided. And it depends on the applications and it depends on the scenario. That's where I can assign some of these computing powers just for that purpose, for that time being. Again, good topic for those of you who are interested, because that is a problem that I'm facing right now that I'm solving. And so one more thing, once you actually solve this, as I mentioned, that it also poses a certification problem, because as I said, FAA kept it in such a way, aviation industry kept it in such a way, a dedicated hardware for a reason. It's so that you can isolate the problem, and then any of one of the failures does not necessarily cascading over to all the other aircraft system. By introducing this, you would have to be very careful of that, and then you can actually isolate the problem. Although we are using that Ethernet as a backbone and sharing all the data, you need to have a great architectures about isolating the problem, and then so that it's not one failures of one of the compute devices not failing entire vehicle. So another certification the challenges, the headache that we're giving over to FAA. In order to get to the fully automated vehicle, there are multiple steps that I'm thinking industry is thinking. First is to simplify the vehicle. If you think about your vehicle, the automotive on the ground, none of us were here, but when Ford first came up with a vehicle, that the way that people drive back then compared to with your ADAS system, it's a huge differences. So automotive industry has been transitioned in order to meet the the requirement of make it easier to drive, so that when U.S. citizens, boys and girls, to become 16 years old, they can just take the couple of hours of online training and a few, 30 hours, some 60 hours of driving test and on the road with monitor, and then you can actually try to get the driver's license. We need to have that on the aviations. Keep in mind the numbers that I mentioned it over there. We're severely suffering the shortage of the pilots. Before you even get to the highly automated and removing the human entirely out of the loop, we need to provide a simplified of the way of operating the vehicle, because right now, helicopter is the most difficult, complex machines to operate. And there's a reason that not many people actually can do it. And it takes years of training a highly intelligent person, and they would have to renew their trainings on every certain durations. So simplified vehicle operations, and then if you've been following the UAM, those are the sort of forefront of the first step of the automating the vehicle. Once that is done, and then the next phase is that now that we know how to simplify we can probably have the human just on the seat just to monitor in case anything happens, but all the operations can be controlled remotely through the connectivities. And once that good understanding is established, and once we actually solve all the problems of the sensors and the object detections and landing spot and making a decision on the spot problem itself, that's when we can actually talk about highly automated operations. So quite a lot of problems. So if you see that some of the OEMs saying from day one, we can actually remove the pilots and out of the vehicle, I have my opinion, but because there are quite a lot of difficulties that in order to get there. I talked about the communications. Right now, the best means to communicate with the air traffic controllers is via voice. And then there's an ADSB there where you're broadcasting and you can subscribe to what other vehicles are actually broadcasting in terms of their intention, their positions, their locations, and their very minimum way of think about it like you have only a way to that you can just text 5 words to the whole world about where you are. So it's not that entire message that you can actually exchange with everyone. It is just that like 3 to 5 words that you're just sharing your intentions. That has to change, again, because that if we actually gonna have a good understanding of that situational awareness problem, and then you want to communicate with everyone, and that poses quite a lot of also challenges right now. Right now that we're trying to minimize the problem in here, so that FAA acknowledge that there's a shortage of the ATC, human personnel problem, so that they're open for introducing brand new players called PSU or ASSP, who are the sort of traffic controllers. So they can FAA now open to have the conversation like what they used to do by the ATC, the tower. Remote located service providers can actually work with individual UAM operators, the fleet operators, and yes, you can fly from from Berkeley campus over to one of the vertiport in San Francisco. I'll give you approval for you to apply for you to fly, and then you can depart in certain hours and then land at certain hours. And so they can do those traffic controls. Brand new players. How are we actually gonna work with them? Because we don't wanna enable the voice again. So that digitalizing the conversation with this PSU is the first problem for industry to solve. And as I mentioned, because they're brand new players, and how do we ensure the integrity of the data that we're exchanging is also one of the problems that I'm looking at it. We can communicate with the person. We can set up the data structures, and then these are the acknowledgement that I'm looking for. These are the messages that I'm going to be sending it over. But if Supernal vehicle as a fleet operator, I'm going to be dispatching my vehicle over to multiple different locations and communicating with them. I want to make sure that there's a way for me to say that, yep, what I get from PSU through the com link is legit. I don't have to worry about anything. So that understanding the integrity aspect of it is the problem that I'm looking at right now. I mentioned about the PSU. Also, remember the graph that we're going to be taking off like exponentially, that's starting in a certain year. Once we have a good understanding of how to automate the vehicle operations, once you introduced multiple different PSUs, so that it's not monopolized by the one person or like one Uber, right? You're using Lyft or Ubers and all the other dispatching providers right now on the ground. Same concept, but then entire network topology data infrastructure has to be well established and well understood. These are the study that I currently working with at NASA, and we've got somewhat good understanding of what that actually is. And then right now we're doing we passed our simulations experiment, and then we're deploying it over to national airspace with FAA starting next year. So anyone's good at backend data infrastructures and network topologies, another area for you to take a look at. All right, so that graph again, if you want to take off exponentially, another gap here is the manufacturing. Number says over here, right? Airspace, you pick up one of the largest OEMs as of today. They produce hundreds because everything is a manual. You saw the vehicle configurations. There are some of the designs I've never seen before. If you want to provide that many, if you want to do that many of the vehicles, supply that many of the vehicle, we need to have a good understanding of how we're actually going to be manufacturing this UAM vehicle in an aviation industry. That's with the current framework. No one solved that problem yet. So I anticipate we need quite a lot of engineers and a good understanding of how we actually going to do that large scale in the aviation industry, because there's a reason that we do it, because it holds a very specific certification where it's going in here. But when it comes anyone with an interest in robotics, that's where we need to fully focus on. Right now in Supernal, that we've got, that is one of the reasons that you see these UAM OEMs are invested by the automotive industry, because they know how to put out the mass number of the manufacturings and the vehicles out there. So that's also the current topic. So for Supernal, I'm not only looking at how to automate the vehicle, because unlike the automotive industry on the ground, where you would have to deal with an undeterministic problem, like unknown problem, because you never know that if again the 5 years old the boy is gonna kick the ball out of nowhere. That is something that you just cannot get ready for. But aviation industry, national airspace, you can actually put quite a lot of restrict. So we can actually, I can try to stay on the known problem and solve the known and unknown problem. They're a known problem because of the whole issues that I mentioned over here, but we're looking at it more holistically, inside and outside of the vehicle. I think that is the right approach, because if you just put out that highly automated vehicle out there, you take a look at if you actually doing the automotive industry problem. There are highly automated vehicle out there, but it didn't get commercialized and right now because of the old undeterministic problem. So for us, I think for me, that is very important that we contribute to entire ecosystem and industry that these are the set of the structure they want to actually implement it, including the UAM corridors, and then so that we can limit the problems that we actually want to tackle, so that we can efficiently automate the vehicle as well as in operations. So yeah, I don't know how I'm doing with the time. I think that's right at clock here. So I'll open up the questions.
Well, thank you for the great talk. We have time for questions. You can raise your hand. I can bring the microphone. Wonderful talk. Thank you. Do you foresee the UAM market to develop like the Boeing Airbus sort of a duopoly, or more like the car market where you have many different manufacturers? So thinking about the zoo of different vehicles that you showed, how do you see that developing?
I think it's a later. You already said that quite a lot of OEMs when it comes to UAM. And now that we've got luxury or the flexibility of coming up with a different design, depends on what they do in terms of the trade studies when it comes to DEP. So I think it's not going to be monopolized by current aviation industry, and then that we cannot take off that, we cannot meet that high number of demands.
Hi, thank you for the nice presentation. So, what is the markets that you envision UAM serving? So it's only going to be cityscapes, or going to be something more rural? I don't think that like emergency vehicles will qualify under UAM, but is there something along those lines?
So UAM, the industry that umbrella under FAA, it's called Advanced Air Mobility. So underneath the UAM is a one segment which carries that small number of the people, passengers, and then sort of 10 to 70 miles of the distance. Underneath the AAM, there's a RAM vehicle, Regional Air Mobility, which is to connect more larger cities, the larger distance between more the rural area and connected with the center of the city. The reason that we're not necessarily focusing on right now is because of the battery problem. You can only go so far with the current existing battery with their architectures. And there's a fine balance that we would have to do in order, we cannot just we cannot put unlimited number of the batteries. So that I would foresee that once that hydrogen fuel cell becomes commercialized and then becomes more of the productized, that's where we can actually serve more of the different use cases.
Hi, thank you so much. So, you brought up a lot of like fancy new technology in this presentation, like autonomous detection and like flight controlling, and then also like air traffic management. Mm-hmm. But the FAA is known to be very stubborn in new things. Like for example, the Boeing 777 winglet took like it's just that little folding mechanism that took like many years to get certificate. Mm-hmm. So, what do you like anticipate FAA's attitude change towards these new technology that you mentioned?
Yeah, it's a good question, because that's my number one problem that I'm facing on a day-to-day basis. So it has to be the small enough sort of the chunk. FAAs, rightfully, they should be paranoid about deploying the large number of vehicle up in an additional airspace. And then they should be paranoid about keeping it safe. So there has to be a fine balance between industry as well as an FAA. So I would say that for past, if you ask me this question 4 years ago, I would say, I don't know. Since you're asking me that today, their attitude has been quite changed. and now we actually see how to move over some of the issues. But we're, as I mentioned, that they're first are focusing on how to certify these various different configurations. And that's their primary focus. And then for that, it's well understood by industry that, yep, we're not going to complicate the problem, right? One problem at a time, so that it's going to be deployed with a pilot. We're going to follow the existing framework. It's going to be a known operational environment. We're not going to be introducing everything all at once. However, these are some of the items that we would have to introduce it. So these are the second priority that you would have to take a look at it. So for today, as of today, that I'm feel more optimistic. I think that for the past few year and a few months, and things are moving with some speed.
Thank you.
Hi, thank you for the talk. That was quite useful for a lot of the projects I'm doing. So my background is actually with UTM prior to Berkeley, but it's specific to like the V2V communications you were talking about. As a provider, would you feel like as Supernal, are you more keen on having a protocol that perhaps is established by the FAA or an authority and allowing for the operators themselves to establish communications and worry about the integrity? Or would that be better done by a third-party UTM provider or private UTM provider that kind of bridges that gap?
I have my personal opinion about V2V. I think that we might be complicating the problem more than it needs to be because of the integrated problem. Getting that redundant data is sure, it's a good thing, but if there isn't any way for me to validate that what's the ground source of the truth, that becomes a quite difficult problem when it comes to data infrastructures and data network. So I think with the current existing sort of through the PSU, that when it comes to protocol, I don't think FAA is gonna be mandating that, like how you guys resolve the problem as an industry. So I think it's the solution will come up from the industries, and then in fact that working with a UTM provider, so that some of the UAM PSU candidates are already existing UTM providers because those are the data they already sort of vetted out, and then so I have a good understanding what the problems are. So,
Thank you. Thanks.
All right.
All right. So
All right.
I think we addressed all the questions, and want to thank the speaker again.
Thank you so much.